Let's take a closer look now at earthquakes, the nightmarish phenomena that can result from our planet's dynamic crust. At the plate's boundaries, a break in the Earth's crust often occurs when there's plate movement. These large cracks are known as faults, like the San Andreas Fault seen here, which marks the boundary where the North American and Pacific plates meet in California. When plates sliding past each other, like those at the San Andreas Fault, grind together, tremendous friction is created. Eventually, the great stress generated by this pressure overcomes the friction. The result is the plates move suddenly, causing an earthquake, which is what happened along the San Andreas Fault in 1989. During that quake in the San Francisco area, the Pacific Plate, in less than 15 seconds, moved more than 6 feet.
To locate and monitor earthquakes, geologists, or specialists known as seismologists, use an instrument called the seismograph to record waves of pressure created by earthquakes. These recordings of pressure are shown on sheets called seismograms. According to geologists, along plate boundaries, there are different kinds of pressure created by changes in the Earth's dynamic crust. The San Andreas Fault, for example, is more than 1,000 kilometers long and divided into many segments. For the segment where the 1989 quake took place, the average rate of movement is 5 centimeters each year. What do you think may happen when there is no movement at all along the San Andreas Fault?
When there is no movement in a plate segment along an active fault line like the San Andreas, the pressure builds up. Experts predict that under these conditions, there is a high potential for an earthquake. Where plate boundaries converge, moving directly toward each other, what scientists call subduction occurs. That is, one plate plunges under the other overriding plate. The 1964 Alaskan earthquake, for instance, was caused by the Pacific Plate pushing under the North American Plate. On the other hand, when plates move apart, there are diverging boundaries. Here, molten rock from the Earth's interior surges up, creating ridges.
The longest mountain range on the Earth's surface, for example, is the Mid-Atlantic Ridge, which lies largely beneath the surface of the Atlantic Ocean. The Mid-Atlantic Ridge was created by the Eurasian and North American plates pulling apart. At its northern end, we can see the Mid-Atlantic Ridge where the nation of Iceland rises above the ocean's surface. Earthquakes on ocean floors, particularly in the Pacific, have generated huge sea waves known as tsunamis. Sometimes racing thousands of miles, the waves gain size as they near the shoreline, surging to heights of sometimes more than 100 feet.
The focus, or main location of a quake within the Earth, can occur at depths up to 700 kilometers. Earthquakes produce 3 different kinds of waves of pressure. Scientists use the varying characteristics of these waves to provide valuable data for research on the Earth's interior. To locate an earthquake center on the Earth's surface, known as the epicenter, experts must calculate findings from 3 different seismographs. The magnitude or strength of an earthquake is measured according to the Richter scale, which determines the amount of energy released by a quake. Each level on the Richter scale is about 32 times stronger than the next lower measurement. The 1989 San Francisco quake measured 7.1 on the Richter, while the stronger 1964 Alaska quake registered 8.3 on the scale. This makes the Alaska quake more than 38 times stronger than the San Francisco upheaval. Most earthquakes occur at the boundaries of plates, but there are some quakes that occur at hidden faults in the middle of plates.
Thus far in the program, we've discussed the theory of plate tectonics and where and why most earthquakes occur.